All right, so let's talk about graphing quadratic functions. So recall the basic quadratic function y equals x squared. The vertex would be at the origin, and the parabola would open up. All right, so let's think now about graphing this quadratic function. So remember, this minus 5 inside the parentheses will shift this basic x squared graph 5 units to the right. So our vertex, which was at the origin, will move over to the right 5 units. So the vertex of this new function, the x-coordinate, would be at 5. Hey, this negative 2 being multiplied in the front. Remember, that negative 2 will multiply every y value on this graph by negative 2. So that will cause this graph to be steeper and skinnier and flip across the y-axis. So this graph would get shifted 5 to the right, flipped across the x-axis, and made steeper and skinnier. This plus 18 out on the end would shift the entire graph up 18. Okay, so again, we'll go 5 units to the right, flip across the x-axis, become steeper and skinnier, and then get shifted up 18. So the vertex, just consider the vertex, will go 5 to the right. It'll stay on the x-axis when it gets flipped, and then it will shift up 18. So the vertex of this function would be at 5, 18. That look clear? So the vertex would be the opposite of this number for the x-coordinate, and the y-coordinate would be 18, just based on basic transformations of functions. Okay, and it should open downward now. Okay, what about the initial value of this function? So remember, initial value is the y-intercept. So to find the y-intercept, you plug 0 in for x. So we just find f of 0. So if I put 0 in here, 0 minus 5 is negative 5. Negative 5 squared is 25. Negative 2 times 25 is negative 50. Negative 50 plus 18 is negative 32. So my initial value would be at negative 32. The vertex we've already found is at 5, 18. Notice again that the x-coordinate of the vertex is the opposite of this number. The y-coordinate would be that number. All right, the roots. The roots are the x-intercepts, or the zeros of the function. To find the x-intercepts, I'm going to plug 0 in for y. So if I put 0 in there, I get 0 is equal to negative 2 times x minus 5 squared plus 18. So this is easy to solve. I'm just going to isolate the part being squared and then take the square root of both sides. So subtract 18 from both sides. I'll have negative 18. Divide both sides by negative 2, and I'll get 9 equals x minus 5 squared. Then I take the square root of both sides, plus or minus the square root of 9 is equal to x minus 5. So x is equal to 5 plus or minus. This one we can simplify. The square root of 9 is 3. So I get x equals 5 plus 3, which would be 8, or 5 minus 3, which would be 2. So my roots would be at 8 and 2. Let's draw our parabola. It's not the most beautiful parabola in the world, but it works. All right, so vertex is at 5, 18. I have two roots at 2 and 8. Initial value at negative 32. Notice, very importantly, A quadratic equation, a parabola is symmetric around this axis of symmetry. A parabola is symmetrical around this axis. So the roots should be equidistant from this axis of symmetry. So if 5 is the x-coordinate of the vertex, then this root should be the same distance from 5 as this root. And you can see that it is. 5 plus 3 is 8, 5 minus 3 is 2. So it's the same on both sides. All right, let's have a look at this example. So first question, is this, will the graph be concave up or down? Will it open up or will it open down? This number in front is positive, so you guys know that that will cause the graph to open up. Vertex. Okay, it's really easy to just look at the equation and know what the vertex is. The x-coordinate will be the opposite of this number, so that'll be -3. And the y-coordinate will be that number. Again, understand why that's true. It's because of transformations of functions. If you take the original x-squared graph, the vertex is at the origin. The number inside will shift the graph left, or shift it opposite of the way of this number. So if it's +3, it'll shift it left 3. And then this number will shift it down 4. So my vertex would then be at -3, -4. Okay, my initial value. Again, initial value just means plug in 0 for x. So f of 0 would be 0 plus 3 is 3. 3 squared is 9. 9 times 1/2 is 4.5. 4.5 minus 4 would be 0.5 or just 1/2. My roots, so if I want a root, that's the x-intercept, I'll plug 0 in for y. So 0 is equal to 1/2 times x plus 3 squared minus 4. To solve that, I will add 4 to both sides. 4 equals 1/2 times x plus 3 squared. To get rid of the 1/2, I'll multiply both sides by 2. So 8 is equal to x plus 3 squared. I need to take the square root of both sides. Remember, you'll get 2 solutions. So x plus 3 is equal to plus or minus the square root of 8. Subtract 3. X is equal to -3 plus or minus the square root of 8. And remember, we can simplify the square root of 8. Let's turn that into the square root of 4 times the square root of 2. X equals -3 plus or minus square root of 4 times the square root of 2. The square root of 4 is 2. So I get 2 times the square root of 2. So my roots are -3 plus 2 times the square root of 2, or -3 minus 2 times the square root of 2. So there's my 2 roots. I'm going to get rid of this, make some room. Here are my 2 roots. All right, let's make a graph of this. So my vertex is at -3, -4, my initial value is at 1/2, so about right there. My roots are at -3 plus 2 times the square root of 2, and -3 minus 2 times the square root of 2. All right, so the square root of 2 is about 1.4 or so. So 2 times about 1.4 would be about 2.8. So -3 plus 2.8 or so would be something just below 0. So that root would go about here. And then negative 3 minus that number would be about here. Okay, so this value is negative 3 plus 2 square roots of 2. It's that value. And this root is negative 3 minus 2 square roots of 2. Okay, so then my parabola looks like this. And we have it graphed. We have the vertex, the 2 roots, and the initial value, which are the important points that I always want you to graph. Make sure you understand that the parabola should be symmetrical around this axis of symmetry. So this root should be the same distance from negative 3 as this root is. Well, clearly it is, because if this is negative 3 plus 2 square roots of 2 here, negative 3 plus 2 square roots of 2, and this one is negative 3 minus 2 square roots of 2. So negative 3 is exactly in between these two numbers. All right, so let's look at a quadratic function, a general quadratic function written in what I call the vertex form. I call this the vertex form because it's really easy to just look and know what the vertex is. So for this general equation, what would be the vertex? Well, the x-coordinate of the vertex would be the opposite of this number, so that would be h. And the y-coordinate of the vertex would just be this number, so it would be k. So if your quadratic equation is written in this form, it's really easy to just look and know what the vertex is. Then another key piece of information is the coefficient out front, this a. If a is bigger than 0, so if a is positive, which way does our parabola open? Well, if a is positive, it opens up, so it's concave up. If a is less than 0, if it's negative, you know that the parabola opens down, so it's concave down. So those are two really important, fast pieces of information you can get about the parabola when it's written in this form. You can just look and know the vertex, and you can know real fast whether it opens up or opens down. All right, let's multiply this out. So let me recopy it. F of x is equal to a times x minus h squared plus k. So let's change this from vertex form into standard form. So to do that, I need to square x minus h. So, and I'll do this really carefully, that'll be x minus h times x minus h plus k. So remember, if you square something, you have to multiply it by itself. It'll be a times, if I multiply this out, I'll get x squared minus xh minus another xh, so minus 2xh. Negative h times negative h is plus h squared plus k. All right, now I can distribute the a through all of those. So I'll have a x squared minus 2 a h x. So I just put all my numbers together. Remember, the a and the h and the k are just some random numbers in the 2. So some number times x plus a h squared plus k. Hey, remember, the a, the h, and the k are all just numbers, so all of this out here will just be some number without an x in it. So you can see now this is written in standard form. I have ax squared plus bx plus c. So remember, c is just some number. This would just be a number. This would be your b, the 2ah. But very importantly, notice the a. So the a, when it's written in vertex form, is the same as the a when it's written in standard form, ax squared plus bx plus c. So that's very important. This a in vertex form tells you whether it opens up or opens down. That's the same as the a in standard form. So this a in standard form will tell you whether the parabola opens up or opens down. All right, so let's have a look at this quadratic function written in standard form. So ax squared plus bx plus c. All right, is this concave up or concave down? So what's my a value? My a value is positive 1. So we know this one opens up. The initial value. Initial value is the y-intercept, or f of 0. Okay, so if I plug 0 in for x, this term will go away, this term will go away, and my initial value will be negative 15. So if a function is written in what I call standard form, ax squared plus bx plus c, your initial value will always be the c, because the other two terms obviously cancel away. All right, the roots. The roots are the x-intercepts, or the zeros. So I need to plug 0 in for y. So let's come over here and do that. So 0 equals x squared minus 2x minus 15. Okay, to solve that, I could complete the square. I could use the quadratic formula, or I could factor it if it'll factor. I was nice to you on this one and gave you one that factors. So 0 equals something times something. I'm going to need an x, I'm going to need an x. Two numbers that multiply to get negative 15, add to get negative 2. That will be minus 5 and plus 3. If I multiply two numbers together and the answer is 0, then either of those could be 0. So either x minus 5 equals 0 or x plus 3 is equal to 0. So either x equals 5 or x equals negative 3. So there are my two roots, 5 or negative 3. Right. Let's make a graph. So my roots are at 5 or negative 3. My initial value is at negative 15. This should open up. It should look like this. Where is my vertex at? Well, remember, the vertex has to be exact, or the x-coordinate of the vertex has to be exactly in between 5 and negative 3. Okay, so what number is exactly in between 5 and negative 3? Well, that would be 1. So the distance from 1 to 5 is 4, and the distance from 1 to negative 3 is 4. So my vertex, or the x-coordinate of my vertex, would be at 1. Well, where's the y-coordinate of my vertex? Well, if I know the x-coordinate, I can figure out the y just by plugging 1 in for x. So if I put 1 in for x, let's work that out. F of 1 would be 1 squared is 1 minus 2 minus 15. 1 minus 2 is negative 1. Negative 1 minus 15 is negative 16. So my vertex would be at 1, negative 16. There. Okay, this parabola should open up. It's going to look like this. And everything makes sense. It's going through the y-axis at negative 15. It is symmetrical around this axis of symmetry. 4 this way, 4 that way. So everything looks good. Alright, so let's look at the general quadratic equation written in standard form, x squared plus bx plus c. Let's pretend that the a is positive. If it was negative, this graph would open down, but let's pretend that it's positive. What's this value? Now this is the initial value, or the y-intercept. So of course this would be c. Okay, what about my two roots? Okay, so you guys know what the roots of a quadratic equation written in this form are. This root would be negative b plus the square root of b squared minus 4ac all over 2a. Here, this root would be negative b minus the square root of b squared minus 4ac all over 2a. Do that one. You can think of these as two different fractions. So let's rewrite this. You could write it as negative b over 2a plus the square root of b squared minus 4ac all over 2a. And you could write this one the same way. You could break it into two fractions. So this would be negative b over 2a minus the square root of b squared minus 4ac over 2a. So all it is break those into two different fractions. And just to clean this up, I'll get rid of that. So that's that root. All right. A parabola is symmetric around this axis of symmetry. So the question is, what is the x-coordinate of this vertex? What is this number right here? Okay, so let's think about it. This has to be, the x-coordinate has to be exactly in between the two roots because the parabola is symmetrical around that. So this root is negative b over 2a plus some mess. This root is negative b over 2a minus that same mess. Okay, so I have negative b over 2a minus a mess, negative b over 2a plus the same mess. So what's this number right here? What is this x-coordinate? Obviously, this would be negative b over 2a. Oh, that's a terrible looking a. All right. So negative b over 2a plus all this mess, negative b over 2a minus all of that mess. So negative b over 2a is right in the middle. Okay, so if a quadratic function is written in this form, the x-coordinate of the vertex is negative b over 2a. That is extremely important. You need to remember that. And it's easy to remember where it comes from if you just remember the quadratic formula. All right, let's graph this quadratic equation. So this is in standard form, ax squared plus bx plus c. Is this concave up or concave down? Well, my a is 1, it's positive, so this parabola opens up. Initial value. Well, initial value, you just plug 0 in for x. So f of 0, cancel, be negative 5. What's my vertex? Well, the x-coordinate of the vertex is negative b over 2a. My b is 3, my a is 1. So negative b over 2a would equal negative 3 over 2 times 1. So you get negative 3 over 2. Okay. How do I find the y-coordinate of the vertex? Well, if I know the x, then it's easy to find the y. Just plug the x value in for x. So f of negative 3 over 2 would be negative 3 over 2 squared plus 3 times 3 over 2 minus 5. This would be 9 over 4 plus 9 over 2 minus 5 over 1. In order to add or subtract fractions, we need a common denominator. So let's use 4. 9 over 4 plus 18 over 4 minus 20 over 4. Oh, excuse me, I messed up here. So I should be plugging in negative 3 over 2, so that should be minus 3 over 2, which makes that a minus 9, which would make that a negative 18, minus 18. That looks better. All right, 9 minus 18 is negative 9. Negative 9 minus 20 is negative 29. So the y-coordinate of my vertex is negative 29 over 4, which is just a little bit more than negative 7. Keep that in mind. All right, the roots. Okay, so to find the roots, we should set the function equal to 0. So 0 equals x squared plus 3x minus 5. And this one won't factor, so we can either complete the square or we can use the quadratic formula. I like the quadratic formula. So x should be equal to negative b, so that would be negative 3, plus or minus square root of b squared, so that's 9, minus 4 times a is 1, times c is negative 5, all over 2 times a. Simplify that. We have negative 3 plus or minus the square root. 9 plus 20, or 29, all over 2. So my roots would be negative 3 plus the square root of 29 over 2, or negative 3 minus the square root of 29 over 2. Or you could just write it like this, that would be fine. All right, let's make us a graph. So anytime I say graph it, you should always have the initial value, the 2 roots, and the vertex. All right, my roots are at negative 3 plus the square root of 29 over 2. So what is the square root of 29 approximately? The square root of 25 is 5. The square root of 36 is 6. So the square root of 29 is somewhere between 5 and 6. So if you did negative 3 plus something between 5 and 6, you would get a positive number. If you did negative 3 minus something between that, you would get a negative number. So, and my vertex is at negative 3 over 2. So that's about right here. The x-coordinate of the vertex is negative 3 over 2. So my roots, let's put 1 here, and an equal distance out here, 1 there. This root would be negative 3 plus the square root of 29 over 2. This root would be negative 3 minus the square root of 29 over 2. Okay. The y-coordinate of my vertex is at negative 29 over 4. Should be there. Okay, so my parabola opens up. My initial value is at negative 5. Let's make sure that makes sense. Negative 29 over 4, that's around negative 7. Negative 28 over 4 would be negative 7. Negative 5 is just above it, so that makes sense. And my 2 roots are equidistant from the x-coordinate of my vertex. I have negative 3 over 2 minus square root of 29 over 2, and negative 3 over 2 plus square root of 29 over 2. So everything makes sense.